Okay, let's go for the part 4. Now I'm gonna give you more hard time in terms of the challenges that we have in the field of cognitive neuroscience. And these challenges are not just about kind of making you frightened about the complexities of the field, but they are going to give you ideas about the challenge that we have and how we might be able to find solutions. So I'm really hopeful that you guys would be able to contribute to the field to be able to solve these problems. But it would be good to have a good idea about the challenges that we have in the field. So in the next few parts, I'm going to give you an idea about the major challenges that we have in the field, and we can start to think about the potential solutions that we might face. As we have discussed about before, we are doing different studies in terms of the response to drug cues. And when we talk about, let's say, right amygdala, we have a sort of habituation response in right amygdala. We have discussed about that before. But the question is, when we talk about right amygdala, what are we talking about when we talk about the activation in the right amygdala? And what is really amygdala? And we discussed that amygdala could have different subnuclei inside. There are different classifications. For example, there are people who are dividing amygdala to lateral nuclei, basolateral, basomedial, medial, and central nuclei. And they have different connections. They receive information from hippocampus, thalamus, from prefrontal insular cortices. They could have output to areas in brain stem, so they could have downstream targets. So there could be different nuclei within amygdala. And what I was discussing with you was about generally amygdala, but I was not discussing about, when I was talking about fMRI in amygdala, most of the time I'm not talking about different nuclei within amygdala. So I need to go into the details of these nuclei to be able to have a better understanding about how amygdala is working. And not only about these nuclei, but also within those nuclei, there are different neurons, different clusters of neuron projecting different types of chemicals. For example, we have GABAergic neurons from centrolateral amygdala to centromedial part of amygdala, or from centromedial to outside. Or we have glutamatergic neurons. So the neurons that we have in different nuclei within amygdala, they could have different chemical characteristics. And even if I zoom in to what I'm showing you right now in basal amygdala or central amygdala or centromedial amygdala, neurons that we have here, they have different receptors, different chemical characteristics. This is not just one single type of neuron. We have different types of neurons here. And that would make things even much more complex. So we have different clinical features, the different characteristics, the neurochemical characteristics. And then when I talk about right amygdala, it is not the level of resolution that I can discuss about all those details that I'm talking about amygdala. So that is one of the first challenges that people would face, that when we talk about fMRI would not give us that, let's say, neural circuit level information. And it is just a general, let's say, activation within amygdala. We cannot say which neural circuits or which specific parts of the amygdala is involved. Now with the kind of the precision that we have in imaging measures, we can divide amygdala to few parts. Let's say, if you remember, in Brainotome Atlas, we were dividing amygdala to medial amygdala and lateral amygdala. Or there are some atlases that they divide them in 3 or 4 parts. But it is not still at that level of cellular, molecular precision that I was discussing about before.